The following functions describe the motion of a dolphin over time t in 0 to pi. P of t, the position of the dolphin. E minus t psi. The level of the ocean surface is said to be 0. So we have the surface levels here, 0 here. The dolphin, I just draw a fish here. And then it is under the water now. According to the values of P negative, dolphin under the water. P is positive, it is above the water. And 0 when it is at the surface level. The dolphin is under the water at the beginning, come out of the water and then go back in. It's come out of the water. So there's a moment where it reaches the surface level 0 and then go back in. Find the speed of the dolphin with which it goes back into the water. So we look at this moment. So at the beginning, let's see, at the beginning the time is 0. These ones never be 0. So it really depends on the side. These terms, whether 0 or not, it can go to the surface level. So t equals 0. This is sine of minus pi over 2. So minus 1. So this is negative, it does make sense. And then it's go into the surface level. The first time it gets 0, t increasing, you get 0. So you have P of t equals this. Sine of t minus pi over 2. So this is a unit circle. We are working with t between 0 and 2 pi. 0 and 2 pi. And then the angle here, they give us t minus pi over 2. So between minus pi over 2 to 3 pi over 2. Minus pi over 2. And t increasing 3 pi over 2 until here. So just on full circle. So we look at this. You see that side axis is this vertical axis. Here the side axis. And then you have at t equals 0. At the time t equals 0 is here. T equal to 0. Psi is minus 1. So it is under the water. And then it go on the surface level. Psi is 0. So it's here. The first time the dolphin go to the surface level and come out of the water. Psi t equal to pi over 2. T equal to pi over 2 at this moment. So sine pi over 2 minus pi over 2, sine 0. This angle 0 equal to 0. The dolphin is coming out of the water for the first time. So this is t minus pi over 2 is 0. And then it is out of the water. I note it here. T equal to pi over 2. And now we want it to go back into the water. And in order to be that, this one needs to be 0 again. Go back to the water. So we need to be at this moment here. The dolphins go back to the water. So we want that the angle here, t minus pi over 2 equal to pi. This angle is pi, equal to pi all t equal to pi plus pi over 2, 3 pi over 2. So the moment the dolphin go back into the water is at the time t equal to 3 pi over 2. T equal to 3 pi over 2. The dolphin go back into the water at this moment. And we need to find the speed of the dolphin. So find the speed. And the speed is just a derivative of the position, p prime here. And the speed is absolute value of the velocity. So we find absolute value of p prime at t 3 pi over 2. This is what we need to do. Compute this one. And now we set it on up. It is easy for us to just compute p prime and then set it at 3 pi over 2. Here's our function p. P prime t. We need to do product rules. E minus t prime. Let me do it slow. d over dt of the first term. And the second term is just this. T minus pi over 2. Plus e minus t. Second term. Sine t minus pi over 2. The first term minus e minus t. Second terms sine t minus pi over 2. And plus e minus t. You do the chain rule. Sine u prime cosine. U prime, which is 1 cosine t minus pi over 2. So this is p prime at t. And we need to compute p prime at 3 pi over 2. And then we compute the absolute value of that. Minus e minus 3 pi over 2 sine 3 pi over 2 minus pi over 2. This term's sine of pi, so this term 0. The other terms here, e minus 3 pi over 2 cosine 3 pi over 2 minus pi over 2. This term's 0, sine of pi. This term non-zero here. We have e minus 3 pi over 2 cosine pi. Cosine pi is minus 1. Minus e is minus 3 pi over 2. So that is derivative, the speed. So this is the velocity. The speed is absolute value of the velocity, which is e minus 3 pi over 2. So this is our final answers.